This video is on measures of position. With measures of position, we're looking at where does the data fall. Not only is this a pro for looking at measures of position, but it is also a con, because when you're over concerned about where particular items are in your data, you lose sight of what the overall data is about. So too much concern about the position can be dangerous as well as helpful. So you just have to watch that particular component about looking at the position of data values. Another good thing about looking at position of data is that it does give you how it compares to other data values in your set. Now, some measures of position that we've already studied is the quartiles. You are familiar with quartiles. Quartiles divide your data into 4 parts. We have quartile 1, quartile 2, which is also the same thing as the median, and quartile 3. And again, just as a quick review, if we were looking at our data set, we have the minimum value, we have the maximum value. In the middle, you would find your median or your quartile 2, which divides your data into 50%, half and half. And then you find the middle value of the lower half, that's quartile 1. And the middle value of the upper half, and that's quartile 3, and that gives you 25% for each component of your data. And that's just a quick overview of how you find quartiles, and we've done this before in a previous lesson, and so I'm just quickly going through again how you find quartiles, giving you that 5-number summary that you can find when you find quartiles. The new one that we're going to look at today is percentile. So we've done quartiles before. Our new one for today is percentile. And what a percentile does is it's going to break our data down into parts of 100. So look at that prefix to that word, percentile, which breaks it down into 100 parts. So for example, if we were wanting to find the 50th percentile, that is the same thing as finding quartile 2, which we also know is the same thing as finding the median. So those 3 values are one and the same. If we wanted to find the 30th percentile, what that means is we have our data set, and if the 50th percentile is here in the middle, the 30th percentile would be approximately at this location. And when we find the 30th percentile, that means that This is all the data below the 30th percentile, and then this is the data above the 30th percentile. And so the 30th percentile is saying that all the data is below that particular percentile value. Now, if we want to actually find a percentile, what we do first is to arrange our data in order from least to greatest. Just like we were finding the median. Next, we would find the percent for the number of items that we want to find. So if we had wanting to find the 40th percentile and we had 30 data items, we would do 0.4 times the 30 items, which would give us the 12th item. And then we go up one item to select. So with a selection of data here, let me give you a list. We have 44, 56, 58, 62, 64, 64, 70, 72, 72, 72, 74, 74, 75, 78, 78, 79, 80, 82, 82, 84, 86, 87, 88, 90, 92, 95, 96, 96, 98, and 100. So if we're finding the 40th percentile item out of these 30, we found 12, but we're going to add 1 to that, so we're finding the 13th item in that list. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And so 75 is the 13th item, so it is going to be at the 40th percentile for that set of data. Now let's just do another example for a good measure. So let's say we wanted to find the 60th percentile. So we would do 0.6 times the 30. And so that turns out to be 18. So we add 1 to that, and we want to find the 19th item. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. And so that item would be the 60th percentile, or 82 is the 60th percentile item. So that's how we find percentiles. So if we wanted to give a little bit of a formula for that, we're going to do the number of values over the total number of values times 100. And that would be how we would calculate that particular value.